Welcome back. Now let's look at the example code, the sample solution for this problem. Number 1, the exercise. This is a sample solution. It doesn't mean that everything has to be exactly the same in your case. And of course namings and so forth can differ, but you can hopefully get a good idea of how things are, and it's a good example of how to do things right. So let's start. First of all, you see, okay, we have a report. It has any name, that doesn't really matter. And we have those local classes, and we start with the definition section that you see here. So there's a public section that defines a bunch of methods. First of all, the constructor, and we said that we wanted the constructor to also has its importing parameters, the name, tank capacity, and fuel consumption, so that this is always set, and this is defined here. Then there is the method refuel that returns the value of the liters that we'd actually that was given, put into the gas tank of the car. The drive distance, that where you specify the distance in kilometers that should be driven, and get current tank level, that gives you the percentage back of how much tank level is left in this type I. So it's like only the full numbers of percentage, but it's okay. In the private section, we define the data of this car object. It's the name, tank capacity, fuel consumption that we specify at the constructor, and then the current tank level, which is something that is implied and manipulated by the refuel drive distance methods. So this is the definition of the class, and now let's look at the implementation. So in the implementation, you see from here class, end class, the implementation, you see those method and method blocks that each implement a certain method. Now what's not so nice is that you cannot see really the interface of the constructor method, but you can always scroll up and see what do I have here as parameters that is coming in. But this constructor is very simple. You pass the name, tank capacity is also just put in, but fuel consumption per kilometers is divided by 100, so you put it internally in a different unit, so to speak, and the current tank level is 0. That's your initialization. Of course, it's implied in ABAP, but we wanted to make it explicit here, so if any other level you would define, this is where you initialize the object. Now the refuel method, obviously you fill up your tank, and how much goes in depends, of course, what the capacity is and how much you currently have in the tank level. So our liters is the return value defined here. So it's a return value type F. And this is how much does fit into the tank, basically. So this is what you have to pay for at the gas station. And the current tank level after this is, of course, the tank capacity, so the thing is filled up. Drive distance implements the driving, so to speak. You need some gas to do that. And first we want to compute how much gas is needed, and we define a local variable. You can do this, of course, like in any other form, function, or whatever. So we have a data definition here. We'll compute how much gas is needed, and you see that in the distance in kilometers, but also fuel consumption per kilometer. That's why we divided it by 100 here, so we can do this simply and don't have to do it all the time, this division by 100. And so if the gas needed is less than what we currently have, we basically go down to 0. Otherwise, sorry, if it's less, then we can drive the distance, and we can reduce the gas from what the tank level is, so the gas needed from what the tank level was. And otherwise, we'll throw an assertion, so if the car gets stalled without gas, it's an exception. So assert 1 equals 2 is a simple way to basically say, hey, there's an error here, this shouldn't happen, and you get a runtime exception in the program. Of course, in real life you would do something more meaningful, but this is a way basically to say, hey, this is an error, this is wrong, shouldn't happen. And then finally, get current tank level just gets you the tank level, and you want percentage, so again times 100 divided by capacity, and you get the percentage back. So this is how you implement this. You see that the methods always give you the data to the outside and inside. There can be a little complicated computation or whatever, just like with any function, but the point is that these methods only work on their own data of this instance, of the class, and of course they work on the parameters or the return values of the method that you use for the method. Now looking at the main code, so to speak, you see the start of selection. We have three variables: VW Golf, the Porsche, and the Hummer, and we have a constant. 100% is value 100. Okay, that just is to show you that how to use a nice constant. Now I'm creating a VW Golf and say it's a Golf. Tank capacity 60, fuel consumption 7. It's pretty good. The Porsche Carrera GT has more tank capacity, but uses a lot more gas. But it's a lot more fun to drive, I suppose. And then the Hummer, which has more capacity and even loses a lot more gas than that. So those numbers are just ballpark figures, of course. Now let's fill up all the cars. We have here now reference variables. If you look here, we have those reference variables that we defined here. We have create object statements. For each of those create object statements, we create one instance that is pointed to by this reference variable. So we have three object instances pointed to by these three reference variables. And now we can call methods. So we call now the refuel method on the VW Golf. And what will it do? Well, we know that the tank capacity here is 60, so it will get 60 liters of gas. And now the refuel method does return, let's look at the definition here. Refuel returns a value. It would return the value of liters of, how much did we actually put into the car, but in this case we don't care, so we discard the value. So we have a method that returns a result, and maybe we should have stored it somewhere, maybe added it up and paid the bill at the gas station, but we didn't. In this case we ignored the return value and we just call reference variable arrow method name parens to call this method. And the same for the other two objects. So now we have all three objects refueled to their full capacity, and you see the capacities here. Now we drive some distances, and that diminishes the capacity somehow. Whatever is gas is left, and hopefully no car gets stalled, so otherwise you would get an assertion of runtime error here, you would never get here. And then we have a Porsche. We want to take the Porsche, goes to the gas station, refuels, so the Porsche is full again. Now we could see how did it behave correctly. We could either say we can do write statements and look exactly, think about, do the computation in our heads and see, after 300 kilometers, how much should there be still in the tank, and is this right? But if you do write statements, then you have to also look at it as a human to check if it's right, and this is not something you want to do to ensure correctness of a program. And this kind of also already goes into the direction, very faintly, of unit testing, is that you say, I will have assertions, so we'll use different assertions later on, but this is the built-in assert statement where you basically have a Boolean expression behind, and if it's not true, you get a runtime error. So what can we say? We don't need to say really that if it is exact how much gas is left after 300 kilometers, but we want to make sure that something is used, and so we just say the current tank level is less than 100%, and also the Hummer is less than 100%. But since we refueled the Porsche, we want to assert that that tank level is 100%. So we don't really test for the exact values, and we assume the computation is right, but we just want to make sure that those logical steps, refueling and driving, really did happen, and this is a simple and cheap way to do it. So this is the program, and now let's run it, and we can just let it run. I think I have to activate it first, and now let's run it. And to give you an idea of how things really happen, we'll do this once that we debug through the code. This is not something we want to do all the time, because we want to make sure that our programs run without debugging, but in this case it may be a good thing to see what really is happening. So let's hit a breakpoint. Okay, session breakpoint set. Let's go there. Okay, and here we are. Let's look at this. Why are we here? Okay, now to show what really happens here, we want to do this once that we look at the behavior of the program in the debugger. Normally we wouldn't do that, but it's instructive to maybe show how things are behaving. And so let's start here with the create object statement and run the program. Get to the debugger. Okay, so let's switch to a different view here. So let's do the VW Golf. Let's look at this. We see here the VW Golf object is initial. There is type ref to LCL car, and there is nothing in it, so it's initial. Now let's do single step, and there are different ways to step here. Of course, there's single step in is F5, step over is 6. I want to go in because I want to show how the constructor behaves. So when you execute this create object, implicitly it will jump to the constructor for this. You see the program, there is an instance now, a value in this VW Golf variable, and I will jump through the different statements. I will set the variables, and now I'm done with the constructor. I'm done with this object creation of the VW Golf, and here I see that object is really set, and you can also jump to it and you see, aha, name, tank capacity, and everything. You can see the variables that the attributes rather, sorry, of this instance, right? So let's go back to here. We can do the same with the Porsche. We can see the Porsche is initial, and now we go through the Porsche. Now the Porsche is created, and also the Hummer. Let's do that just for the completeness sake. Okay, now this is the reference to the Golf. Refuel means initially the Golf here is tank capacity 60, but the tank level is 0. So if I call refuel now, I will get here, fill up the tank, and come back. So the Golf, looking again here, is filled up. Yes, it works. And so it goes with, I'll jump over that, the Porsche and the Hummer. Now I'll drive the distance. It's the same game. You call the method, something happens inside, we'll jump over it, we'll jump over it. The Porsche is revealed, and here you have the assertions. They all work, and they're done. So you can run the whole program, and you get no error message or anything. Everything runs fine. That's the end of the sample solution, and now we'll go back to the theory part and start with module 2.